Hi friends, here is Lucas. This is a free lesson from my best-selling course about Kotlin coroutines and flow for Android development. You can find the link in the description to get the course for a nice discount. Let's start this section with the question, what is a flow? A flow is a type in the Kotlin Coroutine Library which was introduced in 2019. A flow represents a stream of values that are computed asynchronously. An even shorter description would be that a flow is simply an asynchronous data stream. But what is an asynchronous data stream? The best way of learning is by doing. So let's try to create such an asynchronous data stream. Therefore, let's take this code example. I created a new package called flow in the playground package, and in there I created a new file called one-return single item, and I already prepared some code in there. If you can't see this file in your project, please make sure to pull the latest changes of your current branch. I created the modules about flow later than the ones about coroutines. So it could be the case that you need to pull the latest changes. Of course, if you chose to use the coroutines course empty branch, you won't see this file, as on this branch you can code alongside with me and create those files by yourself. But on the other branches, like the coroutine course complete branch or the coroutine course empty exercises branch, as well as on the master branch, you should see this file now. Let's talk about this code now. It should be familiar to you if you have watched section 8 in the coroutines part of this course, which was about background processing. In the main function, we call the calculate factorial of function, which is simply the function below. And then after we have calculated the factorial, we print it out. The calculate factorial of function returns a single big integer value. And in this function, I added a thread.sleep call in order to simulate a longer running calculation. When we now run this code, then you can see on the right that a single line is printed out, basically just the result that we got from the calculate factorial of function. So right now, the calculate factorial of function returns only a single value. Our goal now is to convert this function, which as of right now returns only a single value, the final result, into an asynchronous data stream that not only returns the final result, but also all intermediate results. So a data stream always returns multiple values. Therefore, let's simply copy this file and create a new file called toReturnList. We now want to modify the calculate factorial of function in a way that it doesn't only return a single value, but a list of values. Therefore, let's change the return type from big integer to a list of big integers. To build a list, we can use the buildList builder function. Now we can use the add function to add new values to the list. Now we don't need the return statement anymore. In the main function, since we now get a list, we now want to use for each on this list. And for each value of the list, we want to use the print with time passed function to print out a message in combination with the time that passed since we started this program. This print with time passed function is a function that I recently added to the utils folder in the playground package. So let's simply print out the current item, and additionally we have to provide the start time to the printWithTimePassed function. We simply define the start time at the beginning of the main function and assign it to system.currentTimeMillis. Now we can remove the second print statement. And we also don't need this result property anymore. If we now execute this code, as you can see, we are now not only getting a single value, but 5 values. At the beginning of the line in the console output, you can see how much time already passed since starting this program. And as you can see, all of these values were returned at exactly the same time. So we basically received all of the intermediate results at the same time at the end. So do we have a data stream here already? I would say no, because in a data stream, the data is received continuously, bit by bit, and not all at once, like we have it here. So let's fix this. But how? Well, we can use a sequence for that. Sequences allow us to lazily compute values. Therefore, let's again copy the current file and create a new one that we call 3 sequences. Now we want to return a sequence, and therefore let's change the return type from list to sequence. To build a sequence, we can use the sequence builder. In sequences, we have to use yield instead of add. The code in the main function stays exactly the same. And if we now run this code, you can see that the intermediate results are not received together at the same time at the end, but at the time they are calculated. So after 23 milliseconds, after 36 milliseconds, after 47 milliseconds, and so on. So now we actually have a data stream, because the data is received continuously instead of only once in the end. However, this data stream is not yet asynchronous, but synchronous. This means that the call to forEach in the main function is blocking our main thread. If we add a print statement after the forEach statement in the main function and execute the code, you can see that this new print statement is only outputted after all the values from the sequence were received. So our main thread can only do work again once we have received all the values of the sequence. This means that the main thread is blocked as long as we are waiting for items of the sequence. So lazy sequences that perform expensive calculations should not be used, for example, on the Android main thread, because they could freeze the UI. The big limitation of sequences is that we cannot call suspend functions from within them. So we can't, for instance, call delay instead of thread.sleep in our sequences, or we also can't use with context, for example, to change the dispatcher. So sequences are always blocking a thread, but what we want to have is that only a coroutine is suspended. So how can we achieve this? How can we get an actual asynchronous data stream where we don't block the main thread? I think you guessed it. We have to return a, wait for it, Kotlin flow. Therefore, let's copy this file once again. And the new file we call for flow. Our function should now return a flow. So let's change the return type from sequence to flow. The flow type and its functions are contained in the Kotlin Coroutines library that we already have included. So we don't need to add an additional dependency to our project. Now, instead of the sequence builder, we can simply use the flow builder. Of course, you will learn all about flow builders later in this section. In the flow builder, we can now call suspend functions. So let's now replace the call to thread.sleep with delay. As you can see, Flow fully supports coroutines. Instead of yield, we now have to use emit to return new values from the flow. Let's also add the flow on operator to the flow and pass the default dispatcher so that the calculation is executed on a background thread. Of course, you will learn all the details of this operator in a later section when we talk about concurrent flows. In the main function, in order to receive values from the flow, we now have to use collect on the flow. Of course, we will talk more about the collect operator later. But for now, all you need to know is that using collect on a flow is similar to using for each on collections. However, we get a compilation error. And this is because collect is a suspend function and we have to use collect from either a coroutine or another suspend function. Therefore, let's use the run blocking coroutine builder for our main function. And then let's launch a new coroutine in which we collect the items from the calculation. When we now run this main function here, you can see that we again receive the values continuously, so after 51 milliseconds, 63 milliseconds, and so on. But what's different now is that ready for more work, so the print statement that we had at the end of the main function, is immediately printed out. So here, the main thread isn't blocked anymore, while the factorial intermediate results are calculated. So now we have finally reached our goal of converting the calculate factorial of function from a function that returns a single value into an asynchronous data stream. I hope that you now have a basic idea what a flow actually is and how a stream of data that is computed asynchronously looks like. Let's now recap what we did in this lecture. In the beginning, we simply had the calculate factorial of function that returned a big integer value. So we received a single value once. And while the calculation was running, the main thread was blocked. Then we changed the function and returned a list of big integers with all the intermediate results. This way, we received multiple values, but also only once when the whole calculation was completed. Again, we blocked the main thread. After that, we used a sequence. And this helped us to receive the intermediate results as soon as they were calculated. So we received the values continuously instead of only once. However, we still blocked the main thread. So the values were not calculated asynchronously, but synchronously. Finally, we arrived at using a flow, with which we were able to continuously receive data without blocking the main thread. We created our first asynchronous data stream. Nice! Now, the last thing that I want to talk about in this lecture is the difference between a suspend function and a function that returns a flow. In suspend functions, we can perform asynchronous operations and then return a single value. In regular functions that return a flow, the flow itself can also perform asynchronous operations. However, instead of returning only a single value, a flow can return, or in flow terminology, emit, multiple values. So if you want to dive deeper into coroutines and flow, then I can highly recommend my complete course that contains everything to fully understand and successfully use coroutines and flow in your apps. We will together create a stock live tracking app that uses flow extensively. You will also learn about state flows, shared flows, channels, and many other topics. You can find a link to the course in the description, and I would love to have you on board.